Welcome to today's video. It can be found in your Unit 3A packet, Simplifying Integer Expressions. This is page 1, the properties of operation. And this is just a few of the properties that in your lifetime that you are going to be learning as a mathematics student. So let's practice our new property. What calculation do you perform to find the total area of this rectangle? And if I put that together, I get 16. Well, I could separate that. I could put it together and say, oh, why not add the 5 and the 3 and make that big long length 8 and just do the width of 2 times the 8 to get 16. Yes, I could do it separately, or I can do them all as one. So those are area models of the distributive property. The distributive property says use the rule. The rule says take what's outside the parentheses and multiply it by the things inside the parentheses. So first do 2 times 5, you can see that, and then add to it 2 times 3. So order of operations says that we have to multiply first and last add. So yes, we know that answer is 16 because we did that one a bunch of times. Okay, let's do this one down here. So 3, and yes, I always draw the arrows as I'm doing the multiplication. This says 3 times 7 plus 3 times 2. Well, 3 times 7 is 21, and 3 times 2 is 6. And lastly, adding that together, my sum is 27. 4 times 9, so I'm going to write down 4 times 9, minus, because that's a subtraction problem here, 4 times 2. I'm going to multiply again first. 4 times 9, whoops, is 36, minus 4 times 2 is 8. So 36 minus 8 gives me 28. Now I could just show you that, oh, well, since I know all of the numbers, why don't I just do PEMDAS and do what's in the parentheses first? Oh, 9 minus 2 is 7, and 4 times 7, if I just do PEMDAS, I'm going to get 28, right? So I can distribute or I can do PEMDAS when I know all the values. Same with this example. I could have added the 7 and the 2 first to get 9, and then 3 times 9 to get that 27. 2 times 11, I'm going to show the steps, minus 2 times 5. 2 times 11 is 22. 2 times 5 is 10. 22 minus 10 is 12. Well, we knew it was going to be that. Well, what happens if you don't know one of the numbers? So can I say n plus 2 equals a number? No. So I can't do PEMDAS because I don't know what that number is. So I have to distribute. And yes, if we were equation solving, it would say, oh, equals like, 26 here. And you would solve this equation. That's coming. But now we're just given 3 times the quantity, n plus 2. That's how you would read that. 3 times the quantity, n plus 2. So I'm going to distribute 3 times the n, 3 times n, plus 3 times 2. And the best that I can simplify that to is 3n plus 6. In those, you'll find out that they cannot be added together because this doesn't have an n on it. 6 doesn't have an n on it. So newts cannot be added to just numbers. 3 newts plus 6, can't add it together. And I say newts for n. I'll make up words. You'll see as we go on to talk about like terms. These are not like terms. That's as simplified for now that I can get. 3n plus 6. Oh, again, another example where we have algebra in it. So I don't know what that a is. I can't solve this. So I'm going to distribute 4 times a, 4a, minus, or negative, 4 times 3. So 4 times a, that's 4a. And negative 4 times 3, that's negative 12. So this is 4a and negative 12. Or for those of you that want to say minus, that's 4a minus 12. That's as simplified as that expression can get. On the next page, oh, we've got one of these riddles. And it says, use the code key in the box below to write the appropriate letter next to each equation or statement. then write that letter in the box containing the number of the exercise. So you have to say, what property is this example showing? So for instance, number 1. They've switched the order of the adding. So there's an XY and an XY. That order did not change. But the 7 is first or second here, but here it's first. So this is the commutative property of addition. This is a Y. This is the commutative property of addition. I know that says XY, just pretend it's an 8. 8 plus 7 is the same thing as 7 plus 8. Okay, no, it's not an 8. It's an XY. So don't let the letters, the algebra, don't let that confuse you. They just changed the order of adding. So number 1 is Y. So down in the code here, I'm going to put a Y where number 1 is. There's a couple others that I want to do with you. And one of them is number 8. If A and B are rational numbers, rational, so they could be decimals, fractions, integers, whole, a positive, a negative. So they're rational numbers. Remember that set Q that we're talking about? Then A plus B is also a rational number. That's what's called closure. So when I add them together, when I do the operation, I'm still going to get an answer that's in the same set of numbers. A and B are rational numbers, and when I add a rational plus a rational, I get a rational answer. That's called closure. Now that was not back on page 1, but it is listed here, so I'm going to show you the closure property ones. And that's right up here at the top. It's the letter I, because it's the closure property of addition. See the adding? So this is the letter I. So 8 is the letter I. That's over here. I'm going to do the other closure one, which is number 16. And it kind of looks like number 8. If A and B are rational numbers, a rational times a rational number will always give you a rational number. Yes, that's true. That's closure. That's the multiplication closure property. That's L. So in this example, number 16 is the letter L. Another one that I'd like to do is number 12. I do the distributive. It kind of looks like the distributive property. X times Y. If I did PEMDAS, this would be XY. And X times XY would be X squared Y. Not X squared times XY, because that would give me X cubed, right? And a 2 and a 1 would give me X cubed Y. You may not understand that, which is why I'm doing this one. This is not a property whatsoever at all. It's a false statement. So this is the false statement. This statement is false. It's the letter T. So number 12 is a T. Number 15. Also a false statement. Subtraction is not associative. So say this is, I'm just going to put a number in here. Just say it's a 3. I'll prove it to you. So 4 minus 3, order of operations, we do that first, is 1. And 15 minus 1 gives me 14. Okay. I would have to do this subtraction in the parentheses here first. The 15 minus 4, I get 11. Then 11 take away 3. Nope, that's 8. So this is not true. False statement. This is a letter T. Just erase this. So you can put any number in here for K. It doesn't work. So that's 0. Well, 0 might work there. 15 minus 4. Yeah, 0 would work. So any number but not 0. Every number has to work for it to be a property. Okay, so the number 15 is also a T. The other one that's not true is the very last one. Division. 3 times the quantity of m divided by 12. Well, you can't switch division. We know that, for instance, say this is 24. 24 divided by 12, that's a 2. But 12 divided by 24, that's a 1/2. Division's not commutative, so you cannot commute division. So that's a false statement. Whoops, 15 was, I'm erasing here, is a T, and 8 is an I, so 24 is also a T. And that's all the ones that I'm going to do. You're going to finish this riddle, and you're going to do simplifying this page. Oh, I don't think you know this yet. No, I'm going to do this page. So, we haven't learned this yet. Simplifying, putting like terms together. So this is where I said I'm going to call numbers and, you know, that are M, I'm going to call it a name. So, -2 monkeys plus 9 monkeys, these are like terms. I'm going to put monkeys and monkeys together, but this doesn't have monkeys on it, so can't add that with it. That's an unlike term. Like terms have the same variable to the same power. Same, so you're writing what I'm writing, same variable to the same power. So these are all m to the first. We don't put the first powers on them. If it's a second power, you would see m squared, but so it's just m to the first. They are like terms. We can add or subtract them using our integer rules. Different sign, subtract, because that's -2 and +9. So different sign, subtract, 9 take away 2 is 7. Take the sign of the larger number, 7m. Plus 8. That's as simplified as that gets. This is 7 monkeys and 8. I don't know what those 8s are. They don't have any letter on them. No monkeys can't be added to the 7 monkeys, for instance. I know it sounds kind of silly, but that's what I do. Ooh, in letter B, I have subtraction with an integer. So first thing I have to do is keep this 5 and add the opposite. Now I have 12 monkeys plus a 1 monkey. Just m means 1, or you can write the 1 there or not. An m is an m. It's a 1m. Sometimes the 1's not written. So a monkey plus 12 monkeys, I'm going to put that together first, is 13 monkeys. And just bring down this -5. It doesn't have an m on it, so they cannot combine. That's simplified. In the next example, -m and -6m. -m and -6m. Or, I know those of you that want to say it's a minus. Okay, then add the opposite. Add up. Well, it's -m, and look, it's -6m. -m, and yes, that's a -1m. Plus a -6m. Same signs, add and keep. And I have -7 monkeys. And you're like, you can't have -7 monkeys. Well, just go with it. I'm going to call it monkeys. And the last one here says 8 and -m and -6m. Or, for those of you, 8 minus m minus 6m. I don't like that. I say 8, -m, -6m. A -m and a -6m, we just saw that over here. Okay, well that's a -7m, right? -7m and an 8 out front. In algebra, however, it's always best if the algebraic term is first. 8 is a constant. It's a numerical constant. It doesn't have a letter on it. It's not an algebraic term. The algebraic term is the -7m, and that's a +8, so I'm going to say +8. Or -7m plus 8. And that's it for today's video. Go back and finish the riddle on page 4. Wow, that was a long one.